Okay. So how'd you guys do? Did you guys understand everything okay?
Is that you?
Not me.
Sorry, it's my husband's computer.
Oh, sorry, I thought you were talking to.
Sorry.
You did?
I thought it was kind of confusing.
Okay.
But
So
I mean,
on
it's
the,
fun.
I can't remember if it's the, I'm going to open up the homework and see, but on the, what's throwing me off is on the quiz, if you guys have taken the homework quiz, is on the one that talked about the cancer spots and figuring out, I mean, that whole thing, and then deciding whether it was equal or more than or less than, that kind of a thing through that problem. That was throwing me for a loop.
Was it the standard deviation they were talking about, or was it the sample mean, or do you remember? Because I remember the question, I just don't remember what it was asking.
Yeah, let me pull it up real quick. So like in, say question 7 was, how is the standard deviation of the distribution of the sample means related to the population standard deviation of the number of cancer spots?
Oh. I didn't really understand it either, but it went in accordance to the homework and in accordance to the quiz. It was pretty much the same. So I just looked for that same question in the homework and went from there. And I got it. I was able to get it right. If that makes sense.
So in the homework, in your homework, you said you had a similar question?
Yeah, I'm trying to pull it up right here.
So then from that, so I mean, while you're looking for that, so like question A, so how's the mean of distribution of the sample means related to the population mean of the number of cancer spots?
Because that's the one that asks if it's equal to, greater than, or less than, right? Is that the one that it asks about with the cancer spots?
Yes.
So then number 12 on the homework, it says, is the mean of the distribution of means greater than, equal to, or less than the parent population mean, the length of the human pregnancy? And I just kind of picked those two answers and it was right for the quiz.
Jared.
Yeah.
The other thing too is on that page, lesson 6, that page that we were supposed to read and go through and follow with part 1. To me, it was kind of a play on words. If you go down to section 4, where it says mean and standard deviation of the distribution of sample means, right there, it gives you those 2 bullet points. And then down below it says, think about the simulations you've observed. The mean of the sample means was always aligned with the mean of the sample. So that I just took it as that, always aligned with. So that's what I tried to remember in my notes, was that in that case it's always going to be equal to. I could be wrong, maybe that's not what they mean, but I got it right on the quiz. So.
No, you got it then.
You're onto something.
So kind of what I understood was the mean, like if you're looking at the sample means, the mean is always equal to the mean. So the mean of the sample population or whatever, the mean of the samples is equal to the mean of the population. So whenever you see the mean, it's just always equal to the mean. I don't know if that made sense. But I just watered it down and I was able to understand it. Does that make sense? So if you have a mean of 166 or whatever it was, for the population, then if you have a bunch of samples and you're trying to find the mean of all of those samples, it's just going to be the same as the mean for the population.
So for this example on the skin cancer one, they're going after 60 to 7-year-old American men, and they sampled 70 men.
Okay. So then the mean would be equal. So the sample, the 70 men, their mean should be equal to the population mean.
Okay. And then on the, so I think because of that answer, I probably screwed up this one. So on the sample size, on the shape, so where it says, suppose the sample size study was 2 instead of 70, then what's the shape of the sample mean? Is it skewed right, normal, or skewed left?
Ben, it looks like you want to say something. Do you want to jump in?
That goes back to your less than 30, right? So in the notes there, it told us that for the purposes of this lesson, we're going to use 30 as our magic number for whether or not something's large or small. So if it's under 30, by definition, it's normal. Am I right?
So
sorry. So if it's above 30, it's normal. Is that what you said?
Yeah, that's right.
Yeah, so it would be, so the 2 would be approximately normal.
2, hang on, 2 is less than 30.
Excuse me,
so,
yeah.
Yeah.
You're right. Go ahead.
So
skewed right.
Yeah, so if the population data is skewed right, then if your sample size is super small, it's going to also be skewed right. So like 2 is less than 30. So for the purposes of this class, it'll be skewed right.
Yeah. So if I'm going from 70 to 2, then that's what would push it skewed right.
Right. So if you have a population of 70, then it would be normally distributed. Is that kind of what you were getting at, Ben?
Correct. Yep. Thank you.
Yeah, no worries. You had it. You were good.
Yeah, I figured I was on the right. I mean, I got that one right, but I was basically putting that 2 together. I just wasn't sure if my thoughts were correct or not.
Good.
Cool. All right.
Well, I'm spinning my head all on this. It's not quite there yet. So all those good are Ben. All those are great questions.
Yeah, we'll get through this.
Do you guys want to go through the group quiz or?
Yeah, let's do it. Let's jump in.
Okay.
Definitely.
Okay.
I can, I guess, start it off. I always like to take the easy ones first off the way.
Go for it.
So question 3. So when you are taking a sample size of n equal 5, what is the shape of the distribution of means histogram when the parent population is right skewed? Skewed right.
Yep.
Then when you are taking a sample size of n equals to 100, what is the shape of the distribution of means? Histogram when the parent population is right skew. I put normal on that one.
That's what I put.
And then 5 is when you are taking a sample size of n equals 5. What is the shape of distribution of means? Histogram when the parent population is normally distributed. Normal. And when you are taking a sample size of n equals 100, what is the shape of the distribution of means? Histogram when the parent population is normally distributed. I put normal on that one. And for 7, I think I got partial. I don't think I have all of them, but I'll read the last one here. It says, when would the distribution of means be normally distributed? I have data are drawn from the population that's normally distributed and the sample size is small. And then data are drawn from the population that is normally distributed and the sample size is large, so A and B. I know I'm missing one, but I don't know if it's the third or the fourth. That's kind of, or maybe I'm not sure.
I think, wouldn't it just be the first two? Or D as well?
Yeah, it's D also. Because remember, again,
Okay.
if the sample size is super big, then it doesn't matter what the parent population looks like. Whatever that is going to be. Sorry, guys. I'm like so tired. I'm not even thinking right now. Okay. I'm sorry.
This is you not thinking, then, man. I'm.
That's what I was thinking.
I don't even want to compare.
Oh, no.
That's exactly what ran to my mind.
Putting us to shame.
Then, I guess I can stop now.
Oh, you can keep doing. You can keep going. You're doing a great job.
All right.
You can read grade if you want.
Unless you want. Yeah, go for it, Taylor.
Yeah, we're on number 8. Which of the following gives the best explanation of the central limit theorem? And I put, it's C.
Yeah.
Oh no.
D? Was that?
Oh, yeah, you're right.
Approximately normal.
D.
Yeah.
D.
They're so close because
Yeah.
both the population and it has to be large.
I just remember the central limit theorem has to do with the shape. I don't know if that would help anybody else.
That would, yeah.
Okay. All right. I guess, Taylor, do you want to read the next one too, or I don't know?
Yeah,
Okay.
for sure. I can keep going.
Awesome.
So question 9, let X be a random variable with the population mean U of 10, population standard deviation of 6. Sample size is N equals 36 and is drawn from this population. So what is the distribution of sample means?
The mean, oh, sorry, go ahead.
Oh, no, go ahead.
Oh, I just remember this. The mean of the means is the mean. So it's just 10.
Yep.
Okay, cool.
And question 10, what is the standard deviation of the distribution of sample means? 6.
No.
It's 1, isn't it?
Hang on. So the standard deviation is going to be, remember that formula? It'll be the standard deviation. Standard deviation, yeah, divided by the square root of n.
Oh, okay.
Yep.
Oh, wait, you're right. Hang on, Jared, did you say 1? Someone said 1.
I came up with 1, but I wasn't sure if that was it.
Yeah, plug it into the form here.
Yep, 6 divided by 6 is?
Oh, no.
You guys are brilliant.
Okay, number 11. Regardless of the distribution of the population, the sample size is large, n is greater than 30. What would be the shape distribution of the sample mean? It would mean it's larger. Well, wouldn't it be normal though if it's larger than
30 and above?
Okay, and number 12, what theorem would justify your response to the last question? The law of large numbers or the central limit theorem? The law of large numbers.
So it's talking about the shape, right? So wouldn't it be the central limit theorem?
Based on your definition, yeah.
But then it's also talking about.
Well, no, it would be central limit theorem because yeah, your sample is around 30 or greater. I think they said in the video this is how we determine accuracy. So.
Right. So. So if you had a large sample, then, and if you're talking about the law of large numbers, the law of large numbers relates to the mean, not the shape.
Right.
So if you have more numbers that you're sampling or whatever, then the mean of those is going to be closer to the mean of the population. But the central limit theorem is talking about the shape. So for the question 11, it was asking about the shape. So that's how I came to the conclusion about the central limit theorem.
Okay.
But I don't know if you guys agree with that.
Yeah.
I'm open for debate.
Last time we disagreed with you, we got it wrong. So
No debate on my behalf.
Oh goodness. Watch us bomb it this time. Just kidding.
No, we did good.
You did good? Okay.
100%.
Oh, sweet.
Nice.
Awesome sauce. Okay, cool. Does anybody have any other questions?
I need to study a little bit more. You guys are getting ahead of me on this.
Well, hang on. Just break it down into 4 things. Just remember the central limit theorem and how it relates to the shape. Remember the law of large numbers, and that relates to the mean. And then the formula for the standard deviation of the sample. It's just super simple.
Yeah.
And then just the mean equals the mean. That's really basically all this lesson is. Just those 4 things.
Cool beans.
Very
Yeah.
Thank you,
nice.
Susanna, for all your help. Sorry that I'm not very good with technology.
You know, Google Hangouts is hard because there's those 2 like platforms you can use, and it's kind of confusing
Yeah.
sometimes. Okay. Cool.
Thank you.
You guys are awesome.
Thanks, guys. You're
Thanks,
great.
Sue.
Take
Have
care.
a good trip.
Thanks. Bye.
Bye.
Bye-bye.